Well, guys, we're the Green Titans, and my group consists of Jayden, Matthew, Nolawi, me, Holly, and Dhruv. But Dhruv won't be here with us today because he has other activities which have occupied his morning. But he had helped a lot in helping us create the logistic regression model and help code this site with especially the results part and a lot more. So let's get started. CSB is Counterfeit Swiss Banknotes Project. So it's an AI model that detects counterfeit Swiss banknotes. All you have to do is put in the dimensions of the note. So about 1 in 100,000 banknotes in Switzerland is counterfeit, and only about 1,000 counterfeit banknotes are confiscated each year. This is why the CSB detection team has been attempting to solve the problem of identifying counterfeit Swiss banknotes. In order to make this process of catching, identifying, and thwarting the use of counterfeit bills, it's evidently impractical to catch each person each time they print a counterfeit bill. Instead, it should be caught when the bill is about to be used.
This means that the business or person that is receiving this bill should be able to verify the bill is real or counterfeit. Hence, they should be equipped with the skills and tools to do this. By using the growing popularity of the technology of AI, with our machine learning project, anyone with access to the internet will be able to verify the originality of the bill being used. This can contribute a skill set to the people that have no knowledge on these aspects and are vulnerable to fall victim to being scammed by these counterfeit bills. They will be enabled to identify and restrict further use of counterfeit bills in the nation. On that day, we can exclaim the statement mission complete.
Plots. The main change analyzing in the bottom times plot is the bottom measurements for counterfeit bills tend to be much larger than the real bills, which you could tell by the yellow counterfeit and blue real ones. The next plot we decided to use would be length and diagonal. The main change analyzed in this plot would be the diagonal measurements of the counterfeit bills, once more tending to be much shorter than the real bills. Our first 3D plot we decided to create would be bottom times top times diagonal. The two main changes analyzed in the diagonal bottom top plot would be the difference in diagonal measurements and top to top measurements.
For our fourth plot, we used the left, right, and diagonal dimensions, and one of the biggest changes that was analyzed were that the real banknotes show a smaller right size than the counterfeit bills, with barely any plots going bigger than 130 millimeters. And on the other hand, the diagonal measurements are much larger than the real bills and a lot smaller for the counterfeit bills. For the diagonal times bottom graph, we went back to 2D graphs, and in this graph, we were able to find that the counterfeit diagonal lengths are smaller than the legit banknotes. And for our last one, we went right back to 3D plots, and we have the right, left, and bottom. And most of the counterfeit bills have right measurements that are much larger than the real bills. And a couple of outliers are seen inside the graph, but other than that, it's pretty much bigger. And now onto our machine learning model. For this project, we used when we were using our machine learning models, it was important that we were able to achieve a higher perfect accuracy. And with the amount of machine learning models we were able to use, we were pretty much striving for perfection, and we got 100%. Every single machine learning model that we developed had a perfect accuracy, and this shows that our data set is extremely clean, well organized, and lacks any unnecessary numbers, which means that it's pretty much a perfect job.
So one of the models that we used in our project was logistic regression, and logistic regression was developed and used to take in data that would then be used to predict the output of future data. In our model, we used the logistic regression to predict how many bills would be counterfeit and how many would be real by drawing a line in between these two ranges.
So another machine learning model we used was SVM or SVC, or also known as support vector machine. SVM would separate data into two classes. Using the data from SVM, the AI would decide if it was counterfeit or not. helping us give us data to achieve our goal.
A model that we used in our code was KNN, otherwise known as K nearest neighbors. In 1951, the first prototype of the KNN was produced by Evelyn Fix and Joseph Lawson Hodges Jr. These two students studied at Berkeley together. The way KNN models work is that it calculates similarities using distance between the 2 points on a graph. Some cons of the KNN would be when working with larger data sets, the information will not be entirely accurate. Some pros for the KNN would be how the model doesn't learn anything during the training period, making it easier to work with. Some real-life applications of the KNN would be categorizing products for companies. An example of this would be separating vegetables with fruits.
Another one of the machine learning models that we used is the decision tree. Created in 1963 at the University of Wisconsin-Madison, the decision tree was a model created to function using supervised machine learning. Decision tree starts at a single point or node and goes on to split out into 2 or more directions. Each branch is a different outcome or answer, and it continues to split until a final outcome or answer is achieved. One of the best examples of this model is buying something online from somewhere, a website usually, that gives you different suggestions based off previous purchase history and search history throughout the website.
In our project, we also used random forest. Random forest was invented by Leo Bremen and Adele Cutler in 2001. This works by constructing multiple decision trees and outputting the mean and mode of prediction of the trees. One pro of random forest is that you can get very accurate classification from using it. It's also able to handle large data sets and prevents overfitting. On the other hand, random forests are not easily interpreted.
Out of the 7 models we used, the 2 of them were gradient boosting and XG boosting. Gradient boosting is an idea initially brought up in the 1990s, which was a response to these 2 men named Kern and Valiant. The question was, can we set a bunch of weak learners to create one single strong learner? And this effective method of machine learning was popularized with the recent invention of XG boosting, or extreme gradient boosting. The way the boosting works is by running multiple weak models in a sequential order. So one will run and give you an output, and the output will calculate the error and then run it through the next classifier. This model will repeat this cycle until it's directed to stop by the model parameters, and this is typically somewhere near 50 to 500. This will allow it to potentially come with very refined and accurate outputs. This is unlike bagging, when you run multiple different models simultaneously and have them vote on which has the most correct output. Now, boosting typically does have a high accuracy without the need of much hyperparameter tuning. Regardless, it does come at the expense of having a very high power consumption rate and is computationally expensive. This causes the model to have a tendency to take time and not be the most efficient way of machine learning.
This is a confusion matrix, and it helps us visualize values to tell us about our machine learning model and how well it's performing. You can see that the false negative and the false positive are both 0, and each model got a 1.00 score, meaning we had 100% accuracy.
So we were going to implement Flask, but sadly we did not have the time to do this. But we were able to get started here, and we used a function called prednote, which you could input the length, right, left, top, bottom, and diagonal values for the bill, like we have done here, and it will compare it with our data sets and then tell us if it's counterfeit or not. And here we have a 0, which would mean that it is not counterfeit. And here we have a 1 value, which means that it is counterfeit. And as you can see, the values inputted are different here and here. In order to make our website, we had also used Bootstrap to help with our templates. And then we also used HTML and CSS to help really customize and add everything that we needed to add into our website. Thank you for your time, and we appreciate your patience.